Hello everyone, welcome to this tutorial for using MATLAB Simulink for Millman theorems. In today's video, I will show you how you can use interesting skills in your project to solve problem like if you have any exercises with the calculation of MATLAB or the calculation of the voltage with Millman theorem or superposition. This video will be used as a lot of skills that you can use in your project to solve problem and to compare your result with theoretical calculation and simulation calculation. If you have like this exercises, you have here the circuit and we have the exercises. Try to read the exercises. So calculate the current flowing through diode number 1 and diode number 2. The two diodes are both in the circuit. In the circuit, using Millman theorem, the two diodes are assumed to be real, identical, and conducting. So both diode number 1 and diode number 2 are real and identical. Real means that for each diode we have internal resistor and we have forward voltage. Okay, we have forward voltage, not ideal diode. So if you want to use theoretical calculation, you can calculate firstly the voltage of its branch. Then you can use other theoretical calculation to find the value of the current flowing the diode number 1 and diode number 2. Unless if you want to compare your result and the accuracy of your result, you can use the software of MATLAB Simulink. So you can implement your circuit in MATLAB and compare your result with theoretical calculation. The first step in this exercises is to transform the two diode, with their assumption. The two diodes here are assumed as real. So we need to transform and to replace the two diode with its assumption. Okay, here the new circuit. The new circuit is the two diode are as a forward voltage, okay, and internal resistor. This is for the two diode, the first one and also the second one. Okay, we have also other components like DC voltage sources. We have a resistor to control the current through the circuit. Okay, we have the current sources. Okay, generates as the current. Okay, here we'll replace. So in this step, you can of course calculate the current using Millman theorem as in the exercises. Okay, you will find the value. Okay, if you want to make sure about your results, you can implement the circuit in MATLAB Simulink. Okay, you can implement the different components here to compare your results with the simulation. Using the simulation, you can be sure about the result. So generally, as we know, the Millman theorems allow us to calculate the voltage in parallel. As you know, and I see that you know very well the expression of Millman theorem for the circuit. Here is the result. Here is the result of analytical or theoretical calculation. The voltage in the branch here is Vm equal this expression. Okay, this is the expression based on the voltage divided by resistor divided by the inverse of the different resistor in the branch, or plus the current bit, because we have the branch of current. Okay, so try now to calculate the value with analytical or with theoretical calculation. Try it, students. Try to make this calculation and to find the value of the m. Then you can use the mile law to calculate the current through this circuit and this circuit. Okay, put your value, and then let's switch to the software to find the value using the software. Okay, here is the circuit in MATLAB Simulink. I have already put the different components together. If you want to show how we put the different parameters or the different components of this voltage source, resistor, current source, etc. Take a look on our previous video. I have already explained how you can use MATLAB Simulink to construct a special circuit in this software. Okay, so here we have the DC voltage source, we have the resistor R1, we have the component of the first diode, the assumption, the internal resistor, and the forward voltage. We have the current sources, okay, and we have the E2, the second sources of voltage, and we have the second assumption of the diode number 2, the forward voltage and the RD. Let's firstly set up the different parameters of the different components. Here E1 is 24. Okay, this is E1 is 24 volts. R1 is 50 ohms. RD is 20 ohms. Okay, E0 is 0.7, it's okay. E0 is 0.7, it's okay. RD is 20 ohm, press OK. And E2 is 5 volt. Double click, okay, it's 5 volt. Press OK. And also we have in the current equal 220 milliamps. Okay, let's insert the value. There, this is in amps, those deck in milliamps, 0.200. Okay. So this is the circuit, this is the parameters, the different components together are connected already. The parameters are well set up. Then we have to implement the measurement components. The measurement components equipment, we have current measurements and voltage measurements. Okay, so we need to calculate the current through the diode number 1 and the current through the diode number 2. Here is the current measurement. Press Ctrl R to rotate the block. So isolate this part to add the current measurements. Here is the connection with the circuit. Okay, and connect the output of the current measurement with a display to show the value. It's the same for the second part. Let's copy paste this component to use it in the second part. Deconnect this part. Okay, and make the connection as the first one. Make the same, the second display to show the value. Okay, so here is the circuit, here is the different parameter, and we have added the equipment for measurement. Now we need to click or press run simulation, and before run simulation specify the stop time or the simulation duration. The simulation duration in this simulation we have shown 0.1 second. Okay, it's okay for this simulation because it's enough for this simulation. Okay, press run to run simulation and to show your result. Okay, the result of the first current is 0.38 amps, and the second current is 0.12 amps. Okay, if you want also to make sure about the measured voltage, you can also take the voltage measurement, connect the voltage measurements here in parallel, of course, to calculate and connect this with another display to show the result. Okay, I try to show the different parts to measure and to compare. Actually, you will be able to compare this results with your theoretical calculation of the exercises. Okay, now it's your turn. Try this out and let me know how it works for you. Okay, don't forget, of course, to subscribe button and share this video with your colleagues and with your colleague students who needs this skills. It's very important skills that you can need in your project or your exercise to compare and to measure the different parameters of the electrical parameters about exercises project, and to use this software in the different theoretical calculation like Millman calculation, Thevenin calculation, or also superposition. Okay, if you have a question, drop them in the comment. I'm here to help you, of course, and see you later.